We are now going to read page 29 in the science textbook and draw an illustration on this page that will help us understand better what they're talking about. It says, directly after the flood, the climate on the continents was much cooler, partly due to continued volcanic activity, throwing ash into the air and blocking some of the sunlight. Do you remember what it was like a few weeks ago when all of the wildfire smoke was blocking the sunlight? It actually made the day about 10 degrees cooler than the weatherman said it was going to be that day. Several days in a row that happened. So let's begin by illustrating the volcano. So let's draw some land. And on our land, we're going to have a volcano. And shooting out of the volcano is an explosion and clouds of ash up into the atmosphere. This ash can travel thousands of miles. If you've never seen video of Mount St. Helens erupting, look on YouTube for that. It is incredible. So hold on just a second. So in this ash cloud, we're going to write ash clouds shade the earth. All right, let's continue reading. Because of the catastrophic volcanic activity during the flood, the oceans after the flood would have been much warmer than they are today. When the fountains of the Great Deep broke apart, heated water from inside the earth would have caused increased temperatures in the oceans. So let's draw a line like this that represents the land under the ocean. And here's the surface of the water. Nice little waves, like you would if you were a kid, drawing a picture. And let's do a big old crack in the bottom of the ocean. Big old crack. And color it in nice and dark, because it's where the earth is broken open and out shoots all this hot water. So you can write hot water. And it said this made for warmer oceans. So write warmer oceans. You can write in print or in cursive, whichever you like on a thing like this. As you can tell, I tend to mix them. So back to reading in the book. Warmer water evaporates faster than cooler water. So let's draw some little lines with arrows showing the water evaporating up into the sky. And what does that form? Clouds. Big old rain clouds. The extensive evaporation would have resulted in huge amounts of precipitation. That means rain or snow after the flood. So let's draw some precipitation. It even rains out over the ocean. It's interesting. I never would have thought that. I didn't think the ocean needed rain. It's already wet enough, but it does. So we're going to write more evaporation and more precipitation. So going back to the book again, the increase in precipitation, together with much cooler temperatures over the continents, set up conditions that led to the Ice Age. A little further into our reading, it said that the summers were 20 to 40 degrees cooler. So let's put over here, cooler temps, short for temperature. 20 degrees to 40 degrees Fahrenheit cooler. So instead of the summer being 100 degrees here, it would have been a high of about 60, which is like a winter day for around here. And a lot of places would have been below freezing, even through a good part of the summer. So you can color this if you'd like, but right across the top we're going to write the equation. More precipitation plus cooler temps equals lots of snow. That's the formula for perfect conditions for a worldwide ice age. Now let's continue reading in the book. Many areas of the earth show evidence of a great ice age. See where we are, we're right here. A time when much of the earth was covered with snow and glaciers. There is evidence that ice covered about 30% of the earth at one time, including northern Europe, most of Canada, much of the northern United States, and parts of New Zealand. There are areas of land that have been eroded by massive ice movements, and many specimens of animals and even people have been found encased in ice. Scientists believe that the summers during an ice age would have been 20 to 40 degrees Fahrenheit cooler than they are today. They also believe that up to 80 feet of snow would have fallen each year. 80 feet. That would be enough to bury our school building completely invisible. Bury the whole church building. You wouldn't even be able to see it. It would be under so much snow. Going back to the book. At this rate, 40,000 feet of snow would have fallen in 500 years. This would have compressed into nearly 4,000 feet of ice, resulting in massive glaciers. If you remember from last year, I believe it was, when we learned about glaciers, glaciers are just snow that doesn't ever melt during the summer. And then when more snow falls on top of it, the weight of that upper snow smashes it down until it becomes ice. Back to the book. The uniformitarian idea of slow climatic changes does not explain what would cause the temperatures to change and does not explain what would cause significantly more snowfall to occur at the same time. On the other hand, the biblical account of the creation of the earth followed by the Great Flood explains how a mostly tropical climate was changed quickly into an ice age and eventually into the climate we see today. It would have had to have changed very quickly to capture people or things like woolly mammoths that we're going to talk about in the next video. Suddenly capture them in ice. If it gradually over thousands of years got cooler, the mammoths would have said, "I'm out of here." But if it quickly changed, they would have been caught and frozen. Back to the book. Today, a wide variety of climates exist around the world. Areas near the poles are cold all year round. Areas near the equator are generally tropical. Some areas are deserts. Most areas are temperate and experience changing seasons. Despite the effects of the flood, God has still provided us with a planet that has a climate that allows us to survive and thrive.